you know what a mainframe is? Or have you ever written COBOL? Maybe not.
Everything that exists around software development has a clone in the mainframe space. It's like Mario and Wario, you know?
Okay, it's a parallel universe. We're all really excited about new technology like Bun and Svelte, but a lot of the software that dictates our lives, like airline bookings and bank transactions, actually runs on mainframes using COBOL. And my friend Louis is the founder of Bloop, which is a startup that is completely dedicated to modernizing all this legacy software that no one understands how to build anymore. I feel like the best ones are often like where they're like, should I say this?
Yeah.
All right, let me show you this or whatever.
I don't think I should pull this IDE up, but they do it anyway. Yeah.
You know something good's going to come from that.
Yeah.
What was the best talk ever, like in terms of the ratings? Do you know?
Oh, I love them all.
Okay. No, not your favorite.
Yeah, fine.
Statistically, because you just said you have a quantitative method.
I mean, firstly, I don't actually know because I haven't really been looking out for that. I'd say, things like, former founders, so Guy Pajani, who you know, and Jonas Tempelstein, we've had previously as well. Jonas previously co-founded Monzo, and Guy obviously previously co-founded Sneak. So those kinds of talks, I think, where they span not just the tech, but also entrepreneurialism. Being in London is a common theme as well, that gets people excited. And I think just generally, it's like a huge vote of confidence when you're, most of the people probably graduated in the last 5 years that attend these events, and they turn up and they see somebody who has built a company worth billions of dollars, basically doing a similar thing to them, and is huge validation. And, people really open up as well. I think we do have some pretty good discussions. And so those probably get the highest ratings of all former founders.
Yeah. Because, and I guess it's just like the least BS, I guess, as well. It's just like, if you're a founder, you can say whatever you want.
Yeah.
So,
they're rich.
Yeah.
Like, they can do what they want.
Yeah.
They can say what they want. And they don't have to worry too much in that environment either, because nothing's recorded. Everybody's an engineer. Like, nobody's trying to do a gotcha or anything like that. It's, good discussion.
Yeah. And maybe that's a good segue to talk about that you are the founder of Bloop, and illustrate that you can do what you want. You have brought me a bottle of Dorset Knob, which is displayed for people that are on the video.
Well, we meant to do this in Dorset. So in the absence of doing this in Dorset, we've got a slice of Dorset in South London today with us.
Well, what is Dorset? Where is Dorset for our American and non-UK listeners?
Dorset is what is it? A county? It's county, isn't it?
County.
County in the south of England. Basically stretches along a piece of coastline called the Jurassic Coast, which is very famous for fossils, and they found lots of interesting sea monsters there recently. They've one recently in this really cool BBC documentary that they called The Sea Rex, which I highly recommend going and seeing down in Kimmeridge in the museum there. And then it goes up a bit, but I love Dorset because I quite like sailing, which is my kind of odd pastime. And the waters of Dorset have lots of nice little natural harbours, which are not too deep, and you can go sailing on a small boat and capsize and stand up and you don't drown, which is nice.
Yeah. Poole Harbour is like the second, is it like the second biggest?
It's like the biggest or the second biggest natural harbour in the world. So there's a lot of dinghy sailing, a lot of like kiteboarding, things like that there. Yeah.
We were supposed to be wearing sailor hats today, but
next time. 10 times.
And Bloop is doing something very different now to what it was when you started out.
Yeah. Well, we started in a very different world in 2021. There was no GitHub Copilot. I think, the biggest open source model at the time was GPT-2. And, initially meeting my co-founder, Gabriel, who's a machine learning researcher by background. My background is more as a kind of classic software developer building like websites, mobile apps, things like that, was how do we solve the problem of code understanding? And at the time, you had to like raw dog VS Code, right? You're like typing
Yeah.
everything you wanted, you copy and paste from Stack Overflow, or you type.
Yeah.
Difficult to remember that world now. So the biggest way to accelerate that workflow for us was to create a really good search engine for code. So we downloaded GitHub. I don't think they sue people that say that. So we downloaded GitHub. We chunked it up into, I think it was like 256 token chunks. We trained we fine-tuned a small embedding model on code. And the result was this VS Code extension where you could type in anything like, how do I make a Stripe payment? And it would find you the most, relevant code from GitHub, essentially, to do that. And with that idea, we actually formed the company, hired our first engineers, raised the pre-seed, got into Y Combinator, and about 1 month into Y Combinator, GitHub Copilot came out. And it was just a better product, ultimately, serving users with open source code, because it had just been trained on all the world's open source code. And, you could personalize what you wanted, what it would produce to a much greater degree than what we could produce, which was search. And so the results were static. They weren't generated by a model, and they were much more difficult to personalize. But we kind of persisted with this idea for a bit, and we moved from open source code search into enterprise code search. So how do you help engineers within extremely large companies with huge code bases talk to each other and kind of share code in a better way? So if I'm an engineer at a huge company, I can type, how do we do payments? And it'll show me, oh, well, you use WorldPay, and here's the last senior engineer to implement that, and here's like the documentation they produced and all the rest of it. So kind of permutation on it. And, that was relevant because obviously in an enterprise setting, the code base is updating very rapidly. And so, training or fine-tuning models on enterprise code is actually really inefficient. It's really expensive to do, and you need like a huge training pipeline to do that. So using a search-based approach, made much more sense for that use case. And that kind of marked the next year of the company's life, I'd say. So this is, maybe a few months out of YC until maybe like a year after that. And we built a great product. We moved from the IDE out into a kind of standalone application where people could do code search. And I think, right around the kind of the ChatGPT moment, which was probably 6 months later, 9 months later, we started seeing a lot of competition in this space. Yeah. And I think, there's maybe something natural about code search that if you're a developer and like suddenly something like the GPT 3.5 API comes out, like what's the first thing you try and build? So basically code search. Yeah. So we had like, 3 competitors probably in Y Combinator alone within a space of 2 batches. There's a bunch of open source tools. At the same time, GitHub Copilot eventually moved from just code completion into being in the sidebar as well with a chat experience, which is similar to what we were doing. And this was a problem in commercial discussions, right? We were talking to enterprises. We made a few sales, but in some really significant sales that would have been really meaningful revenue for us, we just had consistent feedback that we didn't really have enough differentiation versus what they were seeing from GitHub and the bundle, right? Because GitHub is not just code search; it's 40 other products in the bundle. Yeah. And if you're trying to sell just one of those features, even if you believe that your feature is better than what they've done, it's quite difficult to cut through. Yeah. And at the same time, and this is a challenge. Some people have done a really good job of this, but it is hard to prove the productivity benefits of a Copilot. There are companies that do a great job of this. I think we maybe didn't do a great job of this. And so, in articulating that value, we just maybe didn't have enough in the way of hard, concrete evidence that if somebody bought code search, they would immediately save, X dollars in a way where I think if you look at the GitHub marketing page today, there's like all kinds of like white papers and research, things like that they've invested in to really communicate the value of those tools. So that's the world up until the modern Bloop, I'd say.
This episode is brought to you by WorkOS. If you're building a dev tool, at some point, your customers are going to start asking you for enterprise features. WorkOS offers you single sign-on, skim provisioning, and audit logs out the box. WorkOS is trusted by Perplexity and Vercel, as well as Workbrew, a homebrew management startup that I recently interviewed. I just told Mike that WorkOS is the sponsor, and this is what Mike said.
Yeah, so WorkOS isn't paying me any money for this. I pay WorkOS money for this, but WorkOS is like one of the best developer tools I've ever used. It's the documentation and the experience with building with them is so good. Like I initially was almost like, okay, this seems expensive, but then I built an integration with them in about 20 minutes that I had spent 2 days bang my head off the wall trying to build it directly with Okta. And then with WorkOS, I then have many SSO providers supported instead of just one. So yeah, for me, WorkOS is one of the nicest developer experiences I've encountered in the last 5 years, probably. And it's not surprising because a bunch of the developer team are ex-GitHub and therefore very good at their job.
Go to workos.com to learn more. That I think that Microsoft, it seems like they have really tried to create the Office suite for developers and you're competing against that. And if they have it, I mean, even we saw with Office, it's like the Slack challenges that they've had, even after all of that adoption, that Teams is really taking a lot of their share.
Yeah, 100%. And, distribution is really key. They're coming out of the gate. It doesn't matter if they ship a feature a year later because they've already got the list of customers at the renegotiation. They can throw that extra feature into the bundle, right?
Yeah.
So we're always going to have to reach, a kind of escape velocity or die with that kind of product. And I think, we could have continued down that path, but at the end of the day, we started having some really positive discussions around legacy code with some of the customers that we'd been talking to for the original code search product. And, it wasn't like we wanted to shut down code search and we started looking for something else. It was like we saw another opportunity. We did the equation and we said, well, that's a more exciting timeline. I think we'll jump to that actually.
Yeah. And what was the first week of, jumping to that, as you put it?
It was kind of a few conversations and then a reflection on those. So I think the very first thing we learned about was spending some time in San Francisco and going to some dev events and just bumping into some really, high up kind of tech leadership people in very big brand name companies and listening to them just talk about the challenge of legacy code. And the first couple of conversations were legacy in the context of JavaScript. They were considering JavaScript and I think Flow.
TypeScript.
Exactly. To be their legacy, and what they wanted to move to was TypeScript in their case. And they were forecasting it was going to take, a decade of developer time to port from Flow to TypeScript because the type system cannot be mapped one-to-one between all of the different flow types.
When you say, sorry, a decade, do you mean
one developer working solidly for 10 years?
Or 10 developers for 1 year sort of thing?
The same thing. Yeah,
okay.
Yeah.
But they were actually thinking time-wise, it's literally not going to be done until
No, I think they would have got a squad on it, but in terms of cost, it would have been about 10 years of a developer's time to solve that problem because a human needed to, manually reason about, well, what do we do about this flow type? What's the correct translation into TypeScript? So we thought about modern language translation for a little bit. And we started talking about this in the context of some of the customer calls we were still having about code search. We're dropping in, well, what about legacy code modernization? And at some point, somebody turned around to us and said, oh, cool. Yeah, we got a billion lines of COBOL in production. Like, can it do that? And we're like, to be honest, we're like, what's this COBOL thing? Kind of heard of it. And, maybe everybody's got a kind of older relative who's, who worked on it or something like that. But it was a completely new environment because the mainframe, and for those in the audience that don't know, the mainframe historically was this kind of workhorse of an architecture. Originally, the very early business computation was done on mainframes, think like 50s, 60s, with languages like COBOL, which originally were designed to be very readable. You read a COBOL file and it's very different from reading a modern programming language because it's laid out almost like a kind of technical English, or like maybe like a kind of an extension of a maths equation in a way. But a lot of these companies have been rolling this stuff into production for decades, and so people just come along and they build and they build and they build, and you wake up one day and you've got 1 billion lines of COBOL in production. And it's so hard for those companies to move away from that because they've just accumulated it. And there aren't really, a lot of good options. I mean, using humans would take a very long time to convert, right? You have to read the legacy code and then manually write it up into Java, whatever you're moving to. People have been trying that recently, but augmenting themselves with things like GitHub Copilot, ChatGPT. But the measured gains of that are, kind of 20%. So, you're only accelerating that process a little bit. The other options are kind of traditional approaches that don't use any AI, like code transpilation.
Yeah.
So these are taking your COBOL and doing a line-by-line conversion into a modern language like Java.
Which will just create absolute carnage.
Well, yes. I mean, I don't know if there's any examples of like machine-generated code that people like, but I assure you, people do not like machine-generated Java. It reads like, and there's huge differences between these languages. And so, you're not taking full advantage of what the Java language can do, represent things properly as, all your entities as nice objects. You're not necessarily representing COBOL objects in clean Java objects because the types are different in both of those languages. The standard library in COBOL is quite small compared to Java. So, for example, if you want to format a date in COBOL, you have to write a program to format a date. Whereas in Java, you just use one line, right? Java standard date formatter. So, these are all opportunities that we kind of identified. Can we do something that's faster than humans and produces code that's better than automatic transpilation? And, this is something that there's a few different approaches to solve. The most obvious one is like, what happens if you just copy some COBOL, put it into ChatGPT and say, generate Java.
Yeah.
And just copy and paste the output back, right? Now, the problem with this, and the problem with any task involving COBOL, is that there's basically no COBOL in open source. And if you think about how the very biggest models have been trained, they've been trained on GitHub and open source. And that's why they're really good at modern programming languages, because there's so much Java and JavaScript and whatever in open source. So what that means is that the same task performed on COBOL and Java will be much less accurate in COBOL than it is in Java. So this approach was immediately written off right from the outset by us. And we actually ran some really interesting experiments to try and generate synthetic COBOL and fine-tune like the kind of the big open source models on more COBOL and things like that to try and boost their performance. But, there's just like what we were able to achieve is like a drop in the ocean from what is needed to truly solve the problem using that approach. So the system we ended up building was kind of something that morphs the old approaches with something new. So we opted to go down the route of actually statically transpiling COBOL into Java, kind of similar to what I was talking about before, those machine-generated code systems. Yeah. But we optimized the transpiler to produce code that is kind of chunked and structured in a way where it's quite easy for us to then run an LLM over the Java, the machine-generated Java,
to make it
and refactor
readable.
it to be readable, modern, performant, all the rest of it. So, there's two halves to our system. We've got transpiler and we've got agentic refactoring.
And does it go is it like in waves where you run like, okay, let's do the date for, like you were mentioning about like using the standard libraries and stuff.
Yeah.
I'm guessing you're just doing it like, let's do that, and then let's do this other thing, and then let's do this other thing.
Yeah. So these code bases are enormous, like millions of lines. And, the context of the best models will be, 100K tokens. We've done quite a lot of work to understand how much of that context is actually usable. And so the reality is like, at 30K tokens in the prompt, you start to see a lot of performance degradation. And in terms of output, these models realistically can only output a few hundred lines of code before they start spewing garbage. So, we've got to work around that. That's kind of the big limitation. And that means that we have to adopt an incremental approach, right? Which is, how do we make many smaller targeted refactors to this code base? And kind of merge these different changes in a way that, the end product is the modern code base. And the structure is a bit like that, like what you described. So, we have a kind of specialized refactoring pass for dealing with the standard library problem. So, large language models, very good at spotting patterns. They can spot these 300 lines of Java that are kind of machine generated looking, actually just format a date and just replace that with, the standard date formatter. But, there's so many permutations, right? Because every implementation of format a date in COBOL has been done by hand by a COBOL engineer. So every code base has got a different version of formatting a date. So this is something that the LLMs are really good at. It's like taking, 100 examples with slight permutations of the same thing and spotting that can be, all distilled to the same ultimate Java standard library function.
And how does it work if there's kind of like, sort of like jank in the code where it's like they're using a different date format there, they're using a different date format there, and maybe they shouldn't be? It's like, do you sort of correct it? Or is it like you kind of, it's the same, it's going to have the same problems, but.
Yeah. So duplication is a huge one. And we do a lot of deduplication on the code bases. You can literally reduce these code bases, like at least by, 50% in terms of the size of what you started with. A lot of the time, so, literally these code bases have been started in the 70s a lot of the time. And developers developing them today are not the same that originally started off. And actually, they're often in maintenance mode. So often there's nobody on the team who knows the code base in a lot of detail. So if they're implementing any changes, there is a bias to write something new as opposed to reusing an existing program or module. So this is something that is really common, is we see lots of duplication of functionality across the code base.
That makes sense. And I think you told me that the people that do understand it are like quite expensive.
So so we could talk about drivers a bit. So the talent is the reason that everything kind of stems from. So most of your listeners probably will not be seriously considering COBOL as a career path. And that's true of most graduates joining the industry today. And so what that means is many more people retire every year with COBOL skills than join the market. And that means if you're operating a COBOL application and you need to make changes because a lot of these businesses are regulated, regulation forces changes, or if you're in a traditional industry that is facing competition from, you're a bank and then there's neobanks popping up, you are stuffed because you can't get enough engineering resource to make those changes. All you've got is enough engineering resource to keep the lights on. So what are you going to do? Just kind of roll over and let the competition ship, features that potentially are encouraging your customers to leave, or are you going to get into a framework and an architecture and that allows you to be really agile and move quickly? So there is a cost to talent, because as the number of developers shrinks, obviously the cost of each developer is going to go up. But the bigger cost is the competitive disadvantage of being stuck on a platform that doesn't really allow you to move very quickly.
Yeah, and I want to ask like more about the actual like going to market, but one last question on the do they run the Java on the mainframe once they've changed it, or are they also like moving?
Yeah, so this is kind of a hot topic at the moment, which is like running Java on the mainframe. And for many years, you could run Java on the mainframe, but it was like super old versions of Java. And quite recently, they've brought the newer versions of Java onto the mainframe to encourage more people to run Java on the mainframe.
Yeah.
But I have really yet to find a single customer to reach out to us that is interested in running Java on a mainframe. I mean, the way I think about this, you take the circle of people who understand mainframe, you take the circle of people who understand Java, and the intersection of those two things is even smaller than either.
Okay.
So if you're trying to solve a talent problem, ultimately you're not solving a talent problem by running Java.
Also, real noob question. I actually don't think I really understand what a mainframe is.
Yeah.
What is a mainframe?
Well, it's an architecture. It's a computing platform that is distinct from what we know in terms of like x86 architecture or anything like that. So it's got its own chips. It's got its own operating systems. It's got its own languages, IDEs, protocols for connecting to screens. Everything that exists in the world as we know it around software development has a clone in the mainframe space.
Okay.
It's like Mario and Wario,
Okay, it's a parallel universe.
Exactly, a parallel universe.
Okay, that makes more sense. Okay, and so what is it looking like when you go and talk to companies? Like, what does it look like to start working with them?
So typically people come to us today when they know they are moving their code from COBOL to Java.
Yeah.
So we don't spend too much time persuading them to do that, because there's enough people for us to kind of work with at the moment who are already somewhere in that process.
Yeah.
We try and get like a chunk of their code to production as quickly as possible. So these code bases are pretty big, and the key is to answer as many hard questions as you can as early as possible, because there's a risk if you try and take the entire code base from A to B in one step, you'll just die from overcomplication, and then these things, these huge projects can run out of control. So we take a small chunk of code and we isolate it from the rest of the system, and we move it into Java, and then we work with the client to deploy it into the cloud. And we try and choose a cluster that is kind of representative of what we'll see in the larger system. So, where it touches things outside of the COBOL, like, I don't know, writing a file or making a network request or accessing a database, things like that. We try and make sure that
prove.
Yeah, exactly.
Do everything.
Exactly, because otherwise, you end up at the end of that pilot project and the customer's like, well, how long is it going to take us to do the rest of it? And you're like, well, I don't know. So, the pilot is really an opportunity to properly spec the rest of the project. And the other reason why it's important to do that is because often the customer has no idea what they're running either. They've got like one engineer maybe sometimes who knows COBOL, who keeps the lights on, makes very occasional small changes or fixes. And so it's very difficult to kind of have a conversation about, how long is this going to take or how much is it going to cost? So what we do is we just kind of put this into a fixed price package that we ensure the customer again is like, okay, well, if it takes us longer, it takes us longer. We'll eat it. And that allows them to engage with us. We just get in there. We do the analysis, define the cluster, to convert the code, and we do all of our learning during the pilot, basically.
Okay, that makes sense. And so you're basically just offering them, you're going to be able to convert this, you're going to do something, or I guess at the beginning they're kind of taking a bet that this is probably going to work, and it's like, we're only betting this amount.
Yeah.
And if it works, great, because we can actually get this done.
Yeah.
But worst case, it's like this amount of money in it. Yeah.
Exactly. And for an enterprise, it's peanuts for them to run an experiment. We've yet to see somebody not go on from a pilot to do a full project. They tend to be quite successful. And in comparison, it's a much quicker and often cheaper alternative to what they would otherwise consider doing with humans.
Yeah.
Or, and it's kind of not really comparable to automatic translation because, people don't want code that they can't read at the end because it's unmaintainable.
Yeah. I'm just imagining, like, how do they know if it was like successful? Because I guess you mentioned like they don't even necessarily know what this code is doing.
Yeah. So we typically define a kind of evaluation matrix ahead of time. So we say to the client, what is important to you in terms of code quality? And they can tell us, well, it's really important that, we're using this particular open source library, right? Because they will have existing Java developers and Java applications, and, they can personalize the output to their coding style.
Okay, cool.
And we can say, okay, well, how important is it that each database table is represented cleanly as an entity? And, or they can say, oh, well, it's really important that we end up in Java Spring Boot, something like that, like a particular framework. And so, the key to having a happy customer at the end is not to do the project, show them the code, and then be like, are you happy? The key is to say, before you start the work, what would make you very happy? And then for them to really granularly break that down, like to write down what happiness is. And then at the end, it's kind of like, it's like a maths question. It's like, yes, no, yes, no. Yeah.
Okay. That makes sense. And then, but do they have like tests and stuff? Do they typically have tests written in COBOL?
No.
No. Okay.
Well, we haven't seen one yet.
Okay. But because I get what you're saying about like the evaluation of like if the code quality and that like, it uses libraries they want to use and stuff. But how do they know if it actually like does the same thing that the COBOL did?
Yeah. So that's a huge topic of interest to us, obviously, is making sure that when we're moving these very critical applications for the biggest companies, that we don't break anything along the way. And there's plenty of examples of companies that have actually received pretty substantial fines for getting this wrong in the process of migrating their tech.
Because we could be talking about finance, like banks and stuff like that. Yeah,
100%. Like, the regulator sees that suddenly you switch over your system and half your customers can't log into their online banking account the next day, you're going to get fined millions of dollars. So it's really important that we demonstrate that the code performs the same after conversion as it does before. So, how do we do this if there's no tests to begin with? And by the way, the reason why there's no tests is because often these programs have been in production for so long that they're just kind of assumed to be working. And people are quite unafraid to, afraid to touch them. So what, we got a mixture of techniques. I mean, technically we're using a lot of the classic techniques for generating tests, but, where the customer can provide us with data, that's very helpful because we can use historic inputs and outputs to create tests for the code when it's a batch system. For online systems, which are kind of more like, I don't know, when you go to check in at the desk, for your flight, and, there's a kind of green text screen that some agent is looking at. That's what we call an online program. And we can record sessions of that in order to generate tests as well, and use a bit of robotic process automation as well to kind of automate some of those flows. And then there's new techniques as well. So we're actually using language models to generate tests on top of the Java. So once we kind of do the first step transpilation into Java, we can then bolster the tests that we produced originally with additional LLM generated tests. And that's really important because, when we come to do the refactoring, which does use large language models under the hood, obviously large language models make mistakes.
Yeah.
And so they will cause unit test failures at some point. So it's important that we have as many tests covering as many cases as possible.
Yeah, that makes sense. This seemed it's very interesting. It's like, it seems so much harder in some ways, but then probably you have the benefit is that not many people would be mad enough to try and help solve such a hard problem.
Yes. Yeah. So it is a funny one. It's kind of mad. It's also slightly detached from, I think, the crazy hype of like coding agent stuff at the moment in a funny way. So none of the customers that come to us considering working with any of the other coding, generic coding agents that are available. And it's because they can't, because of the fundamental problem that, there isn't really COBOL in the training data of these models, and they're not very good at COBOL. So using a pure LLM-based approach doesn't work. So you have to be, if you want to enter this space, you have to be prepared to build a transpiler. And that's a huge undertaking. There's so many edge cases. The documentation sucks. There's different versions of COBOL. I'm obviously very excited about it, but I feel quite secure for the moment anyway that, we have a niche that is quite well insulated from the wider excitement around agents because of that limitation that is very, specific to legacy code.
Yeah. And what is the vision as well? Because I guess people ask you this, is like, once you've fixed all the COBOL in the world.
Well, then we convert all their Java to something else, right?
Okay. Yeah. That makes sense. There's always going to be people that are like modernizing.
There's a lot of COBOL. I mean, that's the first thing, right? There's like billions and billions of lines of COBOL out there. So it'll take us a very long time to convert all of that. And at the same time, there's, successive waves of technology. I mean, Flow was new not that long ago.
Yeah,
right?
That's true.
Yeah.
That's true.
Now it's something that somebody's trying to buy a solution to convert away from. So, these things, I don't think I see programming languages converging on a single one anytime soon. So as long as that remains true, there's always going to be, work to be done. We're also, there's a whole like maintenance life cycle around these applications. The work doesn't stop once we've converted it. They have to continue to be updated and move on to new versions of Java. There's opportunities to build new functionality as well. So I'd see COBOL to Java, the actual translation, as like a really killer wedge into the enterprise. And that's our way to break in, to prove to enormous companies that are very risk averse that we can solve really difficult problems.
Yeah.
And then build on that relationship to see what else, what other problems we can solve.
That makes sense. So it's not actually just like it's not just like, we're going to migrate this thing and then that's done. It's like it's a start. It's the beginning of a relationship.
Yeah, definitely. Even though today, like, our only product is the code translation part.
Yeah.
But it's, it's valuable enough that we can build a business just out of that. And the rest of, the other products that we can build, this doesn't have to turn into like product one of 40 products that Bloop offers for this to be a big opportunity. Like there is so much legacy code out there, but that in itself is a hard problem. But I think we'd be crazy not to leverage those relationships and that reputation that we're building with the enterprise to not, then help solve other problems that they also face.
Yeah, that makes sense. Maybe my question is kind of like naive in a sense that it's like when you hear, just because you aren't faced with, like I am not faced with like COBOL every day and like mainframes, it's like easy to like compartmentalize something that like you're going to be able to just like fix all of this COBOL in like, and then it's done. So that makes a lot of sense. I wanted to ask you so I think we're coming towards the end, but like I wanted to ask you, because you see a lot of AI stuff in particular. I know you've even written like your own like benchmarking, your needle in the haystack.
Multiple needles in the haystack.
Multiple needles
Very
in the
important
haystack.
distinction.
Sorry, your multiple needles in the haystack benchmark. What dev tools are you excited about at the moment, besides Bloop?
Dev tools am I excited about?
Especially, I mean, AI ones. They've got to be AI.
Yeah.
For you.
I think, okay, this is going to be a really self-serving answer. Basically, I think dev tools are best at tasks where it is possible to deterministically evaluate the result. So what I mean by that is where you could basically run a language model infinitely and test its output deterministically to tell whether it has succeeded or failed. Because the real limitation of a lot of the kind of the LLM-based products that I see on the market today, that a human is actually still in the loop of them.
Yeah.
So a classic example is like you use ChatGPT to generate a website, generate HTML for a website, yada, yada, yada. And then, how do you know if it's done the right thing? Well, a human has to sit there and actually evaluate, is that button in the right place, the right color? And you know what? The human is the slow part. And so you can't really run like these long chained, calls to LLMs because, they're constantly being interrupted by a human doing something. So, there's kind of a wave of products now. I mean, it's difficult to be specific because very few of these are actually on the market, but, maybe if I can take your question and twist it into, like where are things going to go after what's the next big thing that we're going to see in the, 12-month time horizon, maybe, that I'm most excited about. It's the ability to kind of spin up an LLM to go off and do some coding task where it can mark its own homework and it can deterministically say when it's finished or not, because those you'll be able to run for much longer than anything where a human is in the loop. Yeah.
And I guess like the final question maybe is like, do you think that, what do you think development is going to be like in, say, 10 years time?
10 years time. It's funny. I think we wrote our first pitch deck. We had this kind of, evolution of mankind type photo with eventually writing code using natural language somewhere up right at the end at 10 years. And it's happened in 2 years. So, I mean, my record for predicting what's going to happen in 10 years is very poor and is probably an underestimate, is what I've learned. But yeah, I mean, I think there will be two economies, right? There will be the world in which new things are built and startups and individuals, will operate. And that could be anything. I mean, really, it could be, very high level languages, could be things that are enabled through voice. If we figure out like a computer brain interface, then you don't even have to be limited by the words per minute that you can type at. I mean, there's so much opportunity there. But then there's the other economy, which is like all the software that has been built to date, which still needs to be understood and maintained and the rest of it. I think there's a risk that, we're not going to be able to take advantage of all of the crazy stuff that's going to happen in the new economy with all that old stuff. Yeah. And so, I guess that's like a very convenient way of saying that, that's the best, that's the reason why we need to be converting all this old code.
Yeah, I thought it was coming back to that. It was like, it's the analogy of like, there's all this cloud computing stuff.
Yeah.
But everyone's still, the COBOL is locking people into
exactly
COBOL on the mainframes.
The world's going to be crazy in 10 years' time. The ways in which, software is written, is going to be so much more efficient. But if you're stuck in COBOL, So this is the
You're
call to
gonna be-
action.
You're going to be feeling like a Dorset knob.
You're going to be feeling like a Dorset knob. Absolutely. Full circle.
Louis, thank you very much. I think that was great fun, and very, very interesting. Where can people learn more about? If someone's got a load of Cobalt, how can they reach out to you?
Yeah, I'd be amazed if you're like the I don't know. Yeah, I don't want to undersell the podcast. Maybe you've got like a huge Cobalt fan base.
If you have a friend who's struggling with a Cobalt problem,
If you have like a great aunt or uncle who's like working with Cobol and really wants to retire, Bloop.ai, please, reach out to us. We're happy to have a chat. And obviously, we see a lot of people going through these migrations, and we can tell you about what we've seen that works and what doesn't work. And, often it's not a case of actually jumping right into a modernization project. It's just building a relationship, understanding, what AI really brings to the modernization space. And, who knows, in a few years' time, when the business decision or whatever is made to actually move away from the mainframe once and for all, you'll remember that conversation that we had and have that in your back pocket to accelerate your modernization. So, yeah.
Amazing. Well, thanks, Louis, and thanks everyone for listening.
Thanks so much.